Surgical care comprises 40% of total hospital expenditures, in part because surgery has become an extremely wasteful process. Surgical instrumentation makes up a large portion of these expenses. Specifically, excess instrumentation is brought into operating rooms, instruments are lost during surgery, and sometimes, instruments can even be left inside a patient's body. By analyzing the surgical instrument workflow in hospitals, our team has identified a root cause shared by these problems. Hospitals lack instrument-level insight into their operating rooms, resulting in these costly inefficiencies. Small-scale studies at Virginia Mason Medical Center have shown that instrument containers can be reduced by 70 to 80% while improving clinical satisfaction. Yet, hospitals lack the means to obtain these instrument-level insights at scale, making it impossible to implement these changes institution-wide. With MonitOR, hospitals can track intraoperative instrument usage across all of their ORs. Using this information, they will be able to reduce re-sterilization workload by 40 to 80%, prevent instrument loss, and reduce the risk of retained surgical instruments. At the Johns Hopkins Hospital, which has 33 ORs, this translates to a total of $1.3 million in annual cost savings. Extrapolating these numbers to the hospitals across the nation leads to a total addressable market of $400 million, achievable with a 20% reduction in instrument container contents. Assuming we can capture 25% of these savings as revenue, our serviceable addressable market is $100 million. Our customer discovery efforts have indicated that large hospitals are most interested in our solution. Narrowing this down to hospitals with 20 or more ORs gives us a serviceable obtainable market of $55 million. Importantly, this obtainable market is made up of just 8% of the nation's hospitals, enabling us to reach a high early revenue while operating on a smaller scale. Our solution is a human-in-the-loop computer vision system to track instrument usage within the operating room. We begin by first collecting footage of surgical instrument tables from a cart-mounted camera. From this footage, our computer vision algorithm automatically extracts clips in which instruments are being moved, compressing the surgery to less than 10% of its original length. Finally, a human annotator marks each clip with the specific instrument being used. Armed with this information, our team will work with a cross-disciplinary panel of nurses, surgeons, and administrators to implement changes that are safe and cost-effective. Eventually, we will automate instrument event annotation to a point where we no longer require human annotators, significantly increasing our profit margins. To generate revenue, we will package our software and hardware into a service-based subscription. This will include hardware maintenance and upgrades, as well as a customer success representative to engage with clinicians quarterly and implement instrumentation reductions. As mentioned earlier, MonitOR will save a hospital such as Johns Hopkins $1.3 million per year. Based on conversations with purchasing committee members at JHH, we will charge a rate of $10,000 per OR per year, totaling $330,000 in revenue. Factoring in our projected costs, we will make a profit of $135,000 from Hopkins alone. In order to begin generating revenue, we will need to demonstrate instrument underuse and prove the clinical efficacy of our product through a pilot study. This will lead to a clinical integration phase where we implement reductions, measure clinician satisfaction over time, and quantify attained cost savings. Success in these initial steps will allow us to begin selling our product to other hospitals in our primary market segment as we work on automating instrument annotation. Over the course of the Fast Forward U Fuel Accelerator, we have been collecting data from the Johns Hopkins Surgical Training Center, MYSTIC. Using this data, we have built an algorithm that is able to extract 100% of the important instrument events from a surgical video. Meanwhile, we have engaged with innovation arms from several academic hospitals to begin clinical pilot studies. While the ongoing pandemic has stalled these efforts, we are using this time to prepare and submit an NSF SBIR Phase 1 grant, which will support our pilot studies from fall 2020 to 2021. We are seeking $15,000 from Demo Day to support our team to work full-time collecting data in hospitals over the summer. Our immediate next step is to establish a partnership with one of the aforementioned hospital innovation arms to gain access to operating rooms and clinicians. Apart from supporting our team, this funding will also allow us to purchase the necessary hardware to cover several operating rooms at once. These preliminary results will help us transition into an NSF SBIR Phase 1 grant and seek further funding for the clinical integration phase. Alternatively, the $5K prize would still allow us to purchase our hardware while running a smaller scale data collection effort working part-time. Our team is composed of JHU biomedical engineering and computer science students. We are mentored by Dr. Ian McLean, CTO of Sonavi Labs, and Dan Greenberg, Director of Perioperative Services at Johns Hopkins. With medical costs skyrocketing, it is time to create leaner, more efficient hospital systems. At MonitOR, we are taking critical steps to make this ideal a reality. Thank you.